Good morning, students. How are you? I hope you are all well. Till yesterday's voice class, we solved the problems for slope and deflections using a Michaelis method, isn't it? We have three methods to solve the problems in this chapter. One is double integration method, and second one is Michaelis method. These two methods are completed till now. And third method is moment area method. This method is used for a simple beams having single loads, and this method is a graphical method. By drawing the bending moment diagram, we can find the slope and deflections. And this method depends on two theorems. Those theorems are called Morse theorems. Morse theorem 1 is gives the slope at any point of the beam after bending, and Morse theorem 2 is gives the deflection of a point on the beam after deflection after bending of a beam. And these two theorems are based on the bending moment diagrams. Let us go for first theorem, Morse theorem 1. It states that the change of slope between any 2 points on a beam after bending is equal to the net area of the bending moment diagram between those 2 points per unit flexural rigidity. So from these theorems, we can find the slope of the beam at any point, and this gives the change in slope between 2 points. Change in slope between 2 points, that is net slope between 2 points, gives the bending moment diagram between those 2 points per unit flexural rigidity. The mathematically it shows that delta theta is equal to, that is change in slope between any 2 points, gives the integration m dx, that is the area of the bending moment diagram, divided by EI. EI is the flexural rigidity. The integration m dx represents area of the bending moment diagram between those 2 points divided by EI. Simply it represents as A by EI, area of the bending moment diagram divided by flexural rigidity EI. This is the change in slope between any 2 points. And similar equation gives the change in deflection by the Morse theorem 2. Morse theorem 2, it states that the intercept taken on a vertical reference line of tangents at any 2 points on a beam after bending is equal to the moment of the bending moment diagram between these 2 points about the reference line per unit flexural rigidity. So it gives the moment of bending moment diagram. Moment of bending moment diagram means area of the first moment of area of the bending moment diagram about a reference line. First moment of area. So area into distance. First moment of area is area into distance of its CG from a reference line. So mathematically it represents as delta y is the change in deflection or net deflection between 2 points is equal to integration mx dx. Mx dx is first moment of bending moment diagram area per unit flexural rigidity divided by EI. Simply it can be taken as Ax bar by EI. A is the area of the bending moment diagram. X bar is the distance of that area, bending moment diagram area CG to the reference line divided by EI. Ax bar by EI. So these are the two theorems which gives the change in slope and change in deflections between 2 points by taking area of the bending moment diagram between those 2 points. So in these two theorems, we should know the area of the bending moment diagram for a given beam. So if you able to draw the bending moment diagram, then we can find the slope and deflections at any point of the beam by this method, moment area method. So otherwise, the Morse theorem 2 can be also defined as the total deflection between 2 points is equal to the moment of bending moment diagram between the 2 points about the end point of the beam per unit flexural rigidity, that is reference line or end point of the beam. O bending moment diagram యొక్క movement about end point of the beam per unit flexural rigidity is called also the total deflection of the beam between 2 points. Clear? Either this one or this one, the Morse theorem 2. So area and position of the CG, that is A and X bar. In this formula, A is the area is there, and in this formula AX bar is there. First moment of bending moment area. So we should know the area and X bar for different bending moment diagrams having different shapes. So area can be represented as length into height by n plus 1. It is the broad formula, that is the overall formula for different bending moment areas. The area consists of horizontal line, inclined line, parabolic curve or cubic parabolic curve, whatever it is. We can take it as length into height by n plus 1. So length of the diagram, height of the diagram divided by n plus 1, LH by n plus 1. Position of CG, that is that center of gravity of that area from an apex of bending moment diagram. Apex nundi a bending moment diagram apex nundi or one end of the beam nundi center of gravity distance ఏ విధంగా క్యాలిక్యులేట్ చేస్తామంటే L into n plus 1 by n plus 2. L into n plus 1 by n plus 2. Here n is the 0 for horizontal line. N should be taken 0 for the horizontal line. Whenever the bending moment diagram comes horizontal line, then n equal to 0. If n equal to 1 for inclined straight line, if the bending moment diagram is inclined straight line, then n can be taken as 1, and n equal to 2 for parabolic curve, like that, and n equal to 3 for cubic parabolic curve. So n varies from 0 to 3. It depends on the type of bending moment diagram, shape of the bending moment diagram. Clear? In this method, these two formulas are very important. LH by n plus 1, L into n plus 1 by n plus 2. These two formulas are very important to calculate the slope and deflections, and n equal to 0 for horizontal line, n equal to 1 for inclined straight line, and n equal to 2 for parabolic curve, and equal to 3 for cubic parabolic curve. Clear? Let us go for the diagrams. That is the bending moment diagram, generally standard beam bending moment diagrams. So first diagram is, if it is bending moment diagram like this, rectangular shape, length of the beam and height of the bending moment diagram H, then area is equal to L into H, isn't it? And position of center of gravity is L by 2 from one end. X bar equal to L by 2. And if the bending moment diagram is a triangular shape, if the triangular shape, the area is half into L by LH, half into L into H, and X bar is 2L by 3 from apex. Apex nundi 2L by 3 distance, or base nundi L by 3 distance. Here X bar is apex, distance of CG from apex is 2L by 3. This formula is L into n plus 1 by n plus 2 by n plus 3. The L into n plus 1 by n plus 2. So L into n plus 1 means n is 1 for straight line. So 1 plus 1 divided by 1 plus 2. 2 by 3 L. For this parabolic curve, n equal to 2. N equal to 2. So this is the LH by n plus 1. Area is LH by n plus 1, 2 plus 1, 3. LH by 3, and X bar is L into n plus 1 by n plus 2. 2 plus 1 by 2 plus 2, 3 by 4. 3 by 4 L. For cubic parabolic curve, the area is LH by n plus 1. LH by n plus 1 means for cubic parabolic curve, n value is 3. LH by 3 plus 1, LH by 4 or 1 by 4. LH is the area of the cubic parabolic curve. And x bar, that is the center of gravity of the cubic parabolic curve from the apex, is L into n plus 1 by n plus 2. N plus 1 means 3 plus 1 by 3 plus 2 is the 4 by 5 L. X bar is the 4 by 5 L. For cubic parabolic curve center of gravity from apex. For parabolic curve center of gravity from apex, 3L by 4. Like that, you have to remember these formulas. LH by n plus 1, L into n plus 1 by n plus 2 are the formulas for different shapes of bending moment diagrams. Okay, let us go for the first problem by using moment area method. Determine the slope and deflection at the free end of a cantilever beam as shown in figure. Take EI equal to 10 to the power of 4 kilonewton meter square. So here we are going to find the slope and deflection at free end at point B by application of point load. So point load is, how much point load is acting? 20 kilonewtons. So 20 kilonewtons load apply చేస్తే beam అనేది ఇలా bend అవుతుంది. ఇలా bend అయినప్పుడు maximum deflection, maximum slope free end దగ్గర ఉంటుంది. This is the tangent at free end after deflection, and this is the deflection vertical displacement at free end. So this is the YB, the maximum deflection at free end, and this is the theta B, slope at point B after deflection. Okay, this is after deflection the beam shape is. If you draw the bending moment diagram for this, bending moment diagram draw cheste, already that knowledge of bending moment diagram we studied in the chapter 2. How to draw the bending moment diagram? We have 2 points, that is the B point and A point. What is the bending moment at B? What is the bending moment at A? Bending moment at B is 0 because the moments of all the forces on the right side. There is no right side beam, therefore bending moment at point B is 0. And bending moment at point A is the moment developed by all the forces on the right side. What are the forces? 20 kilonewtons is there. 20 into perpendicular distance 5 meters. Sorry, 20 into 5 meters. So totally 100 kilonewton meter. 100 kilonewton meter, which is in clockwise slope. So clockwise movement will be developed. Clockwise movement is negative. Okay, so bending moment at point B is 0, bending moment at point A is 100 kilonewton meter negative. So draw the horizontal line, that is the baseline for the bending moment diagram. Draw the vertical lines from the beam and locate the point A and B on the horizontal baseline. On that horizontal baseline, locate the 0 bending moment at point B, that is located on the horizontal line itself. And bending moment diagram, bending moment at A is 100 kilonewton meter. This is negative side, minus 100 kilonewton meter. Negative side, below the baseline, locate the 100 kilonewton meter on the vertical line of A. And join that 100 kilonewton meter with 0 kilonewton, 0 bending moment by a straight line. Because if there is no load between A and B, the bending moment diagram is inclined straight line. Okay, inclined straight line. And draw the bending moment diagram like this. After drawing the bending moment diagram, locate the center of gravity for that bending moment diagram. How to locate the center of gravity? The center of gravity is at a distance of L into n plus 1 by n plus 2, isn't it? L into n plus 1 by n plus 2. Here L is the how much? 5 meters. Length of the bending moment diagram is 5 meters. Height of the bending moment diagram is 100 kilonewton. So L into n plus 1 by n plus 2 is 5 into n is one value for straight inclined line, n taken as 1. So 1 plus 1 by 1 plus 2. 1 plus 1 by 1 plus 2 is 2 by 3. 2 by 3 into 5. 2 by 3 into 5 is 10 by 3. 10 by 3 meters distance of center of gravity of bending moment diagram from apex. Okay, apex నుండి 10 by 3 meter distance లో center of gravity ఉంటుంది. After locating the center of gravity for this bending moment diagram, calculate the area of the bending moment diagram. Area of the bending moment diagram is a triangle shape. So half into breadth into length, half into length into height. Half into length, total 5 meters, height is 100. So half into 100 into 5. So 50 into 5, that is 250 kilonewton meter square. Area of the bending moment diagram units, kilonewton meter square. It is kilonewton meter, length is meters, kilonewton meter square. Then x bar is 10 by 3 meters. For slope, slope at free end. How to find the slope at free end? The slope at free end formula is theta b equal to, or change in slope between a and b. What is the slope at a? 0. Slope at b is theta b. So theta b minus theta a, that is theta b minus 0, theta b itself. So change in slope formula a by ei. So theta b equal to a by ei, area by ei. Area is 250 kilonewton meter square by ei value is 10 to the power of 4 kilonewton meter square, which is given in the problem. Okay. Therefore, we will get the 0.025 radians. If you convert the radians into degrees, we will get theta b equal to 1.432 degrees. How to convert the radians into degrees? If you multiply the radians with 180 and divided by pi, we can get the slope in degrees. Theta b equal to 1.432 degrees. Okay. Then how to get the deflection at free end? Deflection formula ax bar by ei. That is change in deflection between 2 points. Change in deflection between 2 points formula ax bar by ei. Yb is equal to ax bar by ei equal to, area is 250 meters and x bar is 10 by 3 meters, 250 kilonewton meter square. Area is 10 by 3 meters divided by ei 10 to the power of 4. Simply we will get Yb equal to 0.0833 meters. Okay. This is a change in deflection between A and B or deflection at B, because deflection at A is 0. It is taken as Yb minus Ya is equal to 0.0833 or Yb minus 0. Yb minus 0 is Yb. Yb equal to 0.0833 meters. Otherwise, Yb equal to 83.33 mm. Totally 83.33 mm deflected by the free end after application of point load. Clear, students? Like this, you have to find the slope and deflections at every point of the beam or at any point of the beam by using moment area method. Second problem. Determine the slope and deflection at the free end of the cantilever beam as shown in figure. Also find the deflection under the load. This is the load of point of application of load. Take EI equal to 10 to the power of 4 kilonewton meter square. In this diagram, the cantilever beam is given and the point load is acting at a distance of 2 meters from the fixed end. The total span of the beam is 5 meters. So here the load is not acting at the free end, which is acting at a 2 meters, eccentrically acting. So W equal to 20 kilonewtons. The load acting at a distance of 2 meters from fixed end, what is the slope deflection at free end? And also find the deflection under the load. How much distance it is displaced to the point C. ఇలా డిఫ్లెక్ట్ అవుతే ఇక్కడ వర్టికల్ డిస్ప్లేస్మెంట్ ఎంత, ఇక్కడ వర్టికల్ డిస్ప్లేస్మెంట్ అండ్ ఇక్కడ స్లోప్ ఎంత, ఇక్కడ స్లోప్, ఇవన్నీ ఫైండ్ చేయాలి మనం. ఓకేనా? యాక్చువల్లీ ఈ విధంగా బీమ్ ఈ విధంగా లోడ్ అప్లై చేస్తే బీమ్ పైన ద లోడ్ విచ్ ఈస్ acting at a distance of 2 meters from the fixed end, the remaining part of the beam does not bends. ఇలా బెండ్ అవుతుందంటే అది ఎగ్జాంపుల్ ఇలా బీమ్ ఉంటే if load is applying at a certain distance, the beam bends up to this point and from this point it is straight line. It does not bend the beam beyond the load. Load తర్వాత మనకి beam అనేది bend అవ్వదు, straight line ఉంటుంది. సో straight line ఉన్నప్పుడు ఇక్కడ స్లోప్ ఎంత ఉంటుందో ఇక్కడ కూడా అంతే స్లోప్ ఉంటుంది. If you draw the tangent at this place, the coincide with this beam, and this is the slope at this point and also slope at this point. Slope doesn't varies beyond the load and a deflection varies. This is the deflection at the point of application of load. This is the deflection at the free end. So deflection increases but slope is same as that of the point of application of load. So ఈ diagram కి మనకి ఇచ్చిన cantilever beam కి how to draw the first bending moment diagram. What is the bending moment at point B is 0, isn't it? So bending moment at point B is 0. Bending moment at point C is also 0 because no load acting on the right side of the C point. So bending moment at point C is 0. So what is the bending moment at point A? Bending moment at point A is the moments of all the forces acting on the right side of the section, that is point A. So what are the forces on the right side? 20 kilonewtons is there. Isn't it? This 20 into distance 2 meters. So 20 into 2 is 40 kilonewton meter. So bending moment at point A is 40 kilonewton meter. Therefore, by drawing the bending moment diagram for this, draw a horizontal line, baseline. On that baseline, locate the point bending moment points at B and C. Those two bending moments are 0. Locate on the baseline, and the bending moment at point A is, it is clockwise movement, negative 20 into 2 is 40, so minus 40 kilonewton meter. Below the baseline, locate the point 40 kilonewton meter under the point A. Okay, and by joining the 0 and C, by joining the 0 and 0, it is a horizontal line, and then 0 and 40 kilonewton meter by a straight line, inclined straight line. So this is the triangle formed between A and C, and the 0 bending moment, a straight horizontal line formed between B and C. So this is a bending moment diagram, and locate the center of gravity of this CG. How to locate the center of gravity for this triangle? Where should be located the center of gravity? So area of the bending moment diagram is half into length of the bending moment diagram, that is 2 into height of the bending moment diagram is 40. So total area of the bending moment diagram is 40 kilonewton meter square, isn't it? The area of the bending moment diagram between B and C is 0. There is no area forming between B and C. So area of this triangle is half into length into breadth of this triangle. We will get the total area 40 kilonewton meter square. And X bar. What is X bar here? Here if you want to find the deflection at point B, you have to take the distance of CG of bending moment diagram from the end point. If you find the deflection at point C, then you have to take the distance of CG from this point. So X bar here, if you want to find the deflection at point B, you have to take the distance from B point to CG. 3 meters plus this distance is 4 by 3. Because 2 meters is the length, 2 into 2 by 3 distance to CG ఉంటుంది. So 4 by 3. 3 plus 4 by 3 is 13 by 3 meters from point B. Therefore, slope at free end. Free end దగ్గర slope find చేయాలి అంటే area of the total area of the bending moment diagram between those 2 points divided by EI. ఈ A ను B మధ్యలో ఉన్న area bending moment area ఎంత అంటే only triangle. In this portion, the area of the bending moment diagram is 0. Therefore, A by EI is the 40 divided by EI 10 to the power of 4. 40 into 10 to the power minus 4 radians. So if you convert the radians into degrees, multiplied by 180 divided by pi, then we will get the degrees 0.229 degrees. Theta B equal to 0.229 degrees at point B. And also slope at point C kuda ide. Endukante slope at point C find cheyali ante the area of the bending moment diagram between A and C. Area of the bending moment diagram between A and C anna area of the bending moment diagram between A and B anna ఒకటేనండి. Because ఈ రెండింటి మధ్యలో area of the bending moment diagram 0 కాబట్టి. ఓకేనా? అందువల్ల ఇది theta C కూడా ఈక్వల్. Slope at point B is equal to slope at point C. Then deflection at point T. Deflection at free end. Deflection formula ఏంటి? AX bar by EI. YB equal to AX bar by EI. Area is 40, X bar is 13 by 3 divided by 40 to the power of 4. We will get 0.0173 meters. Otherwise 17.3 mm. This is the deflection at free end. Then deflection under the load. Deflection under the load, YC. If you want to find the deflection under the load, here X bar will be changes. Here if you want to find the deflection at point B, then X bar is 3 meters plus 4 by 3 meters. If you want to find the deflection at point C, the X bar is only 4 by 3 meters from this place point C to center of gravity. So here AX bar by EI, A is the 40 kilonewton meter square into X bar is 4 by 3 only divided by 10 to the power of 4. It will get 5.33 into 10 to the power minus 3 meters or 5.33 mm. So beam will deflect 5.33 mm under the load. Like this, you have to find the slope and deflections for different types of beams. That is cantilever beam with point load at different types of points, different locations. Let us go for the third problem, moment area method. That is example 20. Determine the slope and deflection at free end of a cantilever beam shown in figure. Take EI equal to 18 into 10 to the power of 4 kilonewtons meter square. Determine the slope and deflection at a free end. So it's a cantilever beam with UDL acting on it. It is 7 kilonewton per meter. Total span of the beam is 7 meters. So this is the bending moment diagram for the given beam. What is the bending moment at point B? 0. Bending moment at free end of the beam is always 0 in cantilever, in case of cantilever. And the bending moment at point A. What is the bending moment at point A? The total load is 7 kilonewton per meter applying on the distance of 7 meters. So load value is 7 into 7. 49 kilonewtons. 49 kilonewtons. So 49 kilonewtons acting at center of the load. Total rectangular load which is acting at the center. So 49 into its perpendicular distance from the fixed area. 49 into 3.5. Total half of the distance, half of the length of the beam is 3.5. So 49 to 3.5, 171.5 kilonewton meter. So bending moment at point A is 171.5 kilonewton meter, which is clockwise slope. That's why negative. Okay, negative slope. That is negative bending moment. So while drawing the bending moment diagram, draw a horizontal line baseline under the load diagram and locate the point A and B at the end points. And bending moment at point B is 0. Bending moment at point A is 171.5 kilonewton meter. It is negative of the baseline, that is just below the baseline, negative bending moment. And join this 171.5 with a 0 bending moment by a parabolic curve. ఎందుకు parabolic curve draw చేయాలి ఇక్కడ అంటే between these two A and B the UDL is acting. Whenever UDL is acting between 2 points, the bending moment diagram is parabolic curve. Okay, parabolic curve draw చేయండి. Parabolic curve draw చేసి locate the center of gravity of that parabolic curve diagram, bending moment diagram from apex. How to locate? Formula is LH by n plus 1. Area of the formula is LH by n plus 1. And x bar, the distance of CG from apex is L into n plus 1 by n plus 2. Here n value for parabolic curve is 2. N value for parabolic curve is 2. Therefore, area of the bending moment diagram is LH by n plus 1 kabatti L is 7 meters, H is 171.5, height of the bending moment diagram 171.5 kilonewton meter, divided by n plus 1, 2 plus 1 is 3. So area is 400.167 kilonewton meter square. Similarly, x bar, location of center of gravity from apex. X bar is n plus 1 by n plus 2 into length. N plus 1 by n plus 2 into length. N plus 1 is 2 plus 1, 3 by 2 plus 2, 4. So 3 by 4 into 7 meters. 3 by 4 into 7 is 21 by 4 meters. X bar is 21 by 4 meters. Therefore, slope at free end is A by EI. Theta B equal to A by EI. Area is 400.167 divided by EI is 18 into 10 to the power of 4. We will get 2.22 into 10 to the power of minus 3 radians. If you convert into degrees, 0.1273 degrees. This is the slope occurs at the free end of the beam. Okay. Then deflection at free end. Deflection at free end is YB. YB ki formula AX bar by EI. Area is 401.167. X bar is 21.4 divided by 18 into 10 to the power of 4. We will get 0.21 meters by 18, that is 0.0116 meters. Otherwise 11.6 mm. The deflection at the free end of the beam is 11.6 mm. Like this, you have to find the slope and deflections at different points by using bending moment diagram, area and center of gravity from apex. So these are the 3 problems in this class we are discussed. That is cantilever with point load at free end and cantilever with point load at a certain eccentrically acting and the cantilever with UDL. Again, solve these problems by looking this video and practice the problem by using moment area method. Before going to solve the problems, you have to understand that area, how to find the area and how to locate the center of gravity by using formulas. And learn about the Morse theorem 1 and 2. Okay, I am closing this class at this time. Bye. Have a nice day.